Next, we're going to look at a type of differential equation called the separable differential equation. And basically the idea is just that to start off with, I've got both x and y on the same side of the equation. I also have references to x and y on this side of the equation. And what I want to do is separate them. So everything that has to do with y is on one side, and everything that has to do with x is on the other side. Easiest way to do that at this point is just to cross multiply. If I do that, my new equation would be y dy is equal to x dx. Now remember that with differential equations, the solution is going to be a function, right? So I'm trying to get it to say y equals something. Well, the best way to do that, if I've got a derivative here, what I want to do is undo the derivative, and I'm going to do that by taking the antiderivatives. So I take the antiderivative of both sides, and that's going to give me y squared over 2. And I'll put plus c for now, even though we don't write that. And that's going to be equal to x squared over 2 plus c. Now the thing is, I've got plus c on here twice. I don't want that. So I'm going to take this c and just combine it into this one. C we consider sort of a catch-all constant. It's not a variable like the other letters that you see. So I can just combine those all into one and just catch them all. So this is now going to be y squared over 2 is equal to x squared over 2, just one time writing plus c. And then to get rid of this 2, I can multiply both sides of the equation by 2. And when I do that, we'll see that the 2's gone from here, so I've just got y squared. The 2's gone from here, so I've just got x squared. And I still just put plus c, because taking my catch-all constant, multiplying it by 2, it just makes it a new constant, doesn't really change it. A lot of times you'll see the answer actually left like this, but technically, if our idea is to get y by itself, I would go one step further and put my answer like that. Just, of course, taking the square root of both sides. That's the basic idea. Let's look at one more, just a little bit more complicated. I can see that cross multiplying is not going to work here. I still have the same situation where I have dy dx on one side and I have both an x and a y on the other. But cross multiplying is not going to help me. What I want to do to get this y over here is I'm really going to be multiplying by 1 over y. Right? That's the way I can cancel over here. And then I multiply by 1 over y on the other side as well. Same thing for both sides. And then I do multiply by dx to both sides. So to multiply this side by dx will make it cancel out over here, or I can think of it as moving it over there. However you prefer to think of that. So on the left side we'll have 1 over y dy. On the right side, I'm going to write this as 1/2 x to the negative 1/2 power, if I can. So that idea is that if I take this is equal to 1 over 2 radical x dx. But this, of course, this x is just x to the negative 1/2 power, and then this over here just gives me a 1/2. So I'm just writing it slightly differently. So I'll set this up this way. So I've got 1 over y dy is equal to 1/2 x to the negative 1/2 dx. And now I want to take the antiderivative of both sides. So over here, this antiderivative is just going to become ln y. Technically that's an absolute value of y, but we'll come back to that in a little bit. We'll see that we don't need it really as a problem, of course. And then over here on the right side, this is going to be 1/2 times x to the positive 1/2 power, also divided by 1/2 plus c. So that's just adding 1 to the exponent, right? Usual power rule for antiderivatives. Well, that cancels out those 1/2s. And so now I've got the natural log. Colors matched up. I've got the natural log of y is equal to, we'll put this now as radical x plus c. Almost done, but we got some kind of strange stuff to do solving this and dealing with the c in order to get y by itself, right? The solution of these things is always going to be y equals. So if I switch this form, to the exponential form. So this is just using regular algebra log rules. The idea that if I've got ln y equals x, I can change that to say e to the x equals y. So I'm going to do that same thing, but if in this case it's going to be e to the radical x plus c is equals y. And then with this piece up here, I've got this plus in between. And of course, remember that if I've got like, x cubed times x to the fifth, I add those exponents, right, to get x to the eighth. Well, I can do this in reverse as well. So if I take that same concept, I can say this is going to be e to the, well, I wrote that. I guess my free up here. So this is going to be e to the radical x times e to the c is equal to y. And then again, we've got our little catch-all constant rule right here with this, that e to the c power is just some unnamed constant, which in this whole time we've just been referring to as c. So I could then write this as just e to the radical x times c equals y. And then to clean this up, I would just write it this way. A little bit strange, but just take your time to go through that. It's not that complicated, it's just